Hello everyone. In the last class, we discussed about the convex mirrors. In this class, we will discuss some problematic concepts. So let me write mirrors formula. Mirrors formula. One by F equals to 1 by B plus 1 by U. So this is the mirror formula. From the formula, F is focal length and V is image distance and U is object distance. Object distance. So let me draw the concave mirror. Concave mirror has a curved inward reflecting surface. So oblique lines are taken outside of the mirror. This is the principal axis which is passing through the center of the mirror. So this is pole and focus and center of curvature. So let me represent the focal length and image distance and object distance in the diagram. So the distance of the focus from the mirror is called focal length. It is denoted by small f. The distance of the center of curvature from the mirror is called radius of curvature. Radius of curvature. It is denoted by capital R. So suppose if your object is placed here, then your image is going to be formed in between center of curvature and focus. The distance of the object from the mirror is denoted by U, and the distance of the image from the mirror is denoted by V. Let me tell you a small relation between focal length and the radius of curvature. You can observe the focal length and the radius of curvature from the diagram. The radius of curvature is twice of the focal length. Radius of curvature is twice of the focal length, and focal length is half of the radius of curvature. Focal length is half of the radius of curvature. While you are solving the problem, it will be helpful. Now again, let me draw concave mirror. Concave mirror. This is the principal axis, pole, focus and the center of curvature. The distance of the focus is focal length. The distance of center of curvature from the mirror is radius of curvature. And suppose if you place the object here, your image is going to be formed here. So this is V, and this distance is U. Let's apply the sign conventions. All distances are measured from the mirror. and every distance should be compared with the direction of the incident. I repeat, all distances are measured from the mirror and every distance should be compared with the direction of incident ray. Always direction of the incident ray towards the mirror, and when you are measuring any distance along the same direction of the incident ray, then consider positive. When you are measuring any distance opposite to the direction of the incident ray, then consider negative. Let me tell you. So come to the object distance. So your distance of the object towards left, and the direction of the incident ray towards right, both are in opposite direction, then consider negative. U is negative. Now come to the focal length. The direction of the focal length towards left and the direction of the incident ray towards the right, so both are in opposite direction, so focal length consider negative. Now come to the image distance. So the direction of image distance towards the left and the direction of incident ray towards right, both are in opposite direction, so image distance is also negative. Now come to the radius of curvature. The direction of radius of curvature towards left and the direction of incident ray towards right, both are in opposite direction, so radius of curvature is also negative. But sometimes concave mirror can form virtual images. So virtual image can be formed here. So in this situation, already I told you, every distance must be measured from the mirror. So the distance of the image from the mirror is V. So now the distance of the image, the direction of the image distance towards right and the direction of the incident ray towards right, both are in same direction. Now image is positive. Image is positive for virtual image. So image distance is negative when image is real image. So we have to take negative for real images and we have to take a positive for virtual images. So next, height of the object is h0 and height of the image is hi. All heights are measured from the principal axis. All heights are measured from the principal axis. Suppose any object or image above the principal axis, consider positive. Below the principal axis, consider negative. Now you can observe here object height above the principal axis. So object height above the principal axis, so consider positive. Now your image height below the principal axis, consider negative. But in some situations, for virtual images can be formed. Virtual images will be formed above the principal axis. So this is virtual image. Virtual image. So for the virtual images are formed above the principal axis. So image height is considered positive for virtual images and the image height is negative for real image. Always real images are formed below the principal axis and always virtual images are formed above the principal axis. come to the image distance. Always real images are negative and always virtual images are positive. Let me draw convex mirror and we will see sign conventions for convex mirror. Sign conventions for convex mirror. Convex mirror has a curved outward reflecting surface, so oblique lines are taken inside of the mirror. So this is principal axis and focus, center of curvature and pole. The distance of the focus from the mirror is called focal length, denoted by small f. The distance of the center of curvature from the mirror is called radius of curvature. Let the object be placed anywhere in front of the mirror. Your image is always going to be formed behind the mirror in between pole and focus. Your image is here. So the distance of the object from the mirror is u. The distance of the image from the mirror is v. Let me draw incident ray. The direction of incident ray always towards the mirror. So every distance should be compared with the direction of the incident ray. So now come to the object distance. The direction of object towards left and the direction of incident ray towards right. Both are in opposite direction. So consider u is negative. Now come to the image distance. The direction of image distance towards right and the direction of incident ray towards right. Both are in same direction. Then consider v is positive. Now come to the focal length. The direction of focal length towards right and the direction of incident ray towards right, both are in same direction. So f consider positive. F is positive. So here the radius of curvature and incident ray both are in same directions. So radius of curvature is also positive. U is negative and V is positive, F is positive and R is positive. Now come to the heights. Object height HO and image height HI. Already we know convex mirror always can form virtual images. So all virtual images are formed above the principal axis and always object height is also placed above the principal axis. So HO is positive always, because object is placed above the principal axis. So image height is positive. Image height is positive because of above the principal axis. After sign conventions, let me discuss magnification. Magnification, it is denoted by small f. It tells how the image size is varying compared to the object size. So let me write the formula. M equals to height of the image divided by height of the object equal to minus image distance divided by object distance. This is the magnification formula. When we use magnification formula, then also we have to apply the sign conventions. So now when m is greater than 1, then image is magnified or enlarged. Enlarged image. When m equals to 1, then object size equals to image size. When m is less than 1, then image is diminished image. Diminished image. When m is positive, virtual image. When m is negative, real image. Real image. So let me take one example. When m equals to -3, then we have to see individually. M is negative and m equals to 3. M is negative and that is already I told you real image. When m is negative, real image. And when m equals to 3, definitely m is greater than 1. So enlarged image. Enlarged image. Let me take one more example. When m equals to 0.2, we have to observe individually, sign individual and digit individual. So m is positive. Positive means m is positive, virtual image. And m equals to 0.2. Definitely m less than 1. When m is less than 1, that is diminished image. Diminished image. Okay, this is the today's class. So miscellaneous concepts we will discuss later. Thank you.